Welcome to this new chapter. In this chapter, we will discuss about 802.11 medium access. I will break this chapter down into multiple videos because this is a very detailed chapter, and it's very critical that we understand and watch each and every video carefully. In this chapter, we will discuss about CSMA, CA, and CSMA, CD, and what they are, and how is Wi-Fi different from the wired when it comes to medium access. And also we'll go through some concepts of DCF, which I will talk about in the later videos. Uh, anyway, so moving forward, what we need to understand in CSMA-CA and CSMA-CD is that CSMA-CD is widely known because it is used in the wired networks, or I should say Ethernet space, whereas CSMA-CA is less known or lesser known. It is used in the Wi-Fi space or the wireless space, right? So the two most common forms of contention that are heavily used in today's networks are CSMA-CA and CSMA-CD, which is carrier sense multiple access, collision detection, and collision avoidance. As the name suggests, in one we are able to detect a collision happening between the two frames, in the other we are trying to avoid it. We cannot detect it. Okay. So in both these network access methods, the station first listens to see if the medium is empty or available for me to send traffic or not. The transmitting station, the transmitting station has to first listen in both the methods and see if the medium is available or not. Medium is available or not to send traffic. Okay. Now the difference comes when the station wants to transmit. Okay. That is when the difference arises. Because in CSMA CD, whenever the medium is available, boom, we can send traffic. Good to go. But in CSMA CA, whenever medium is available, it doesn't end there. It cannot straight away come and start sending out traffic. It has to perform some additional checks before it can think, okay, now I can send traffic, right? Since it is half duplex, it cannot send and receive at the same time. So it has to follow CSMA-CA to try to avoid collision. Try to avoid collision. It is not 100% guarantee that the collisions will be avoided, but we try our best to avoid collisions in the Wi-Fi world. Still collisions happen, but we perform certain checks which kind of prevents us, kind of prevents the collisions as much as possible. A quick example would be, let's say, if you don't know, then every or most of the unicast frames in the Wi-Fi world are acknowledged. Okay. If I am sending a frame from the client to the AP, there has to be an acknowledgement coming back from the AP to the client, letting the client know that, okay, I received your traffic. If a frame is sent or any data is sent, there has to be an acknowledgement letting the client know that, okay, I have received your frame. If there is no acknowledgement, then the station will assume that a collision happens. If acknowledgement does not come back, then station A will think, okay, I need to retransmit the frame which I sent earlier here. This is just one example of how, how every or how most of the unicast frames in the Wi-Fi world are acknowledged. And if there is no acknowledgement, then I would know that yes, my frame did not reach the recipient, or my traffic needs to be sent once again. That is one way of preventing. Now, what IEEE did was IEEE defined a medium access standard called DCF, which is called distributed coordinated function. This is a medium access method which is followed by all the clients in the Wi-Fi world. They have to go through this for them to be able to send traffic in the medium. Okay, so DCF we will talk more about in the coming videos. There are four things that DCF does, which which prevents the clients to have any collisions in the Wi-Fi world. So we'll discuss more about DCF in the coming video. See you then. Thank you.